right? So we have triangle SEN. Now the structure of how you write it is very important. So in triangle SEN and triangle OPN. Okay? Some of you, the way you write it is it's very chaotic. It's very, very chaotic. Number one. Right. Let's look at that S there and that O. Now the S that you have, it's in SEN, which will be this angle. Okay? And then the O, it will be that angle. Alright, please, you cannot say that angle O1 is equal to angle S3 and then write your reason as angles in the same segment. Who told you that OPNS is a cyclic part? You can only do that if OPNS is a cyclic part, or you have to prove that it's a cyclic part. First, you prove that the cyclic part first, then that's when you can say, therefore O1 is equal to S3, converse angles in the same segment, or whichever the case you write it. So you cannot just write that. So my suggestion was to do with angle E and N, P and N. Once you prove those two pairs of corresponding angles, then it means that S3 will be equal to O1. So let's move on to E, SEN. This is the angle here. Okay? SEN and P, which is that angle. The good thing is that those two, right, I can just write here, E3, it's E3, is equal to 90 degrees. Okay? Now, have we proved before that E3 is 90? Hmm? If you look at the question,
E4 is equal to 90.
right, then if you proved E4, then you must write the relationship between E4 and E3 as your reason. Why is E3 equal to E4? Okay? So here, my answer here, I'll write it as line from center to midpoint of chord. That's how I would write it. And once I write it like this, I will be on the safe side. Well, there's a line which originates from point O and it passes through the midpoint of the chord, therefore the angle there is 90. Then we also have angle P, so I'll call it OPN. This is 90, that's based on, I think we showed this one here, tan perpendicular to what? To radius. This is straightforward. Okay, therefore angle E3 is equal to OPN. Okay, so we have got that. Then, okay, please, this is not the only way. As long as you do it in such a way that your reasons are clear, they can be seen by the marker, it's fine. But you have to prove that E3 is equal to OPN. Then, number two, we now have angle N. Now, angle N is this one here. That's N1. And then we have got this N here, that's for N2. Now, that one, we'll just write it as N1 is equal to N2. And this you can write as proved. Okay, you can write as proved in what? In question 1. Okay, or I would suggest that you can give your reason here as congruent triangles if you want to. Okay, because that comes from congruency. Right. Once you have got these two pairs of corresponding sides, the third pair is very simple. I've told you that many times. Then number 3 is going to be angle NE, sorry, it will be NS, it will be NSE is equal to, NSE is equal to PON. Okay, this will be sum of angles in a triangle. Therefore, now the order is very important, but because they gave us the names already, we just say triangle SEN is similar to triangle OPN. And your reason AAA. Please don't forget to write triple A, this part here, it's very important. Okay, you get a mark for that part in most cases. If you forget to write it down, then you might lose as an easy mark. Okay, so this is generally the structure. Make it as clear as possible for the person who will mark your work. Make it as, in this case for now it's me, make it as clear as possible. Okay, so this is straightforward. Then the next question, in most cases, the next question which follows after proving that triangles are similar, okay, it has got a relationship with the triangles you proved at the top that they are similar. So Pn squared equal to En times On. That one there, it can come from the proof of similar triangles. Okay. At the same time, I also want you to be aware that because, in fact, I need to write this down before I start that. I need to introduce the concept of the midpoint theorem in the question. Okay, let's move on to the next page. Is there anyone else got a question so far? Okay, let me introduce the mid. Right. So we know that OP is equal to OR. So we are now doing the next question, which is in this case written as 13.22. OP is equal to OR. That's because the radii is circle. And we know that PE is going to be equal to ES. And this here, now the reason for this, if you prove that triangles are congruent, you can put here congruent triangle, or you can just write line from center to midpoint of chord. Tell me, is this difficult to remember? Huh? Because some of the reasons that I see, yes.
It was stated that E is the midpoint of PS, so could you not say it's given?
Okay. That reason, I don't like it. Because one of the reasons is because you know that you can draw a line. Okay, you can draw a line which is not perpendicular to that chord, but it can still bisect PS. Do you agree with me on that?
Yeah.
Is it possible to draw a line which is not perpendicular to the chord, but to bisect PS? Yeah. So my suggestion is to use the converse of theorem 1 to be on the safe side. Okay, that's my suggestion. If you write E is given as the midpoint, to me it's not really very convincing. Okay? In my opinion, this will be the best reason. The converse of theorem 1. Okay, that's how I would do it. Now, because of this, we can say, therefore, OE is parallel to RS. Okay? And our reason there, midpoint. And then the natural effect will be, so what do you think should be should I take as a reason? Okay, so we can put the midpoint here because I was thinking about the converse confusing myself. Therefore, OE is going to be equal to half RS. Okay, so now I'm going to start from there to do that. Now, that one there, I've got SE over OP equal to EN over PN is equal to so SE over OP, then I put EN over PN. Okay, then I have SN over ON. Right? Okay, what do we have? We have got the EN, we have got the ON, we have got the PN, and we have got the SN. But now, what's the relation between PN and SN? They're equal. Why are they equal? Yeah, so I would suggest that I would say right here, but PN is equal to SN. And your reason there turns from common point. Now, if you had proved the congruency, you would have written this down. Okay? If you had proved the congruency, you would have written this down. So you could maybe write a proved in whichever question on top, if you had proved the congruence. But if you didn't, you have to write this reason down. Why Pn is equal to Sn. You cannot just write Pn equal to Sn and then you stop without telling whoever is going to mark the reason why they are equal. You know, it's very surprising. What I saw here, some people writing tan. Remember, it's plural. It's tangents from common point. Someone writing tangent from common point. It's not correct to do that. And that's not how we did it last year. It turns from a common point, or you can say turns from the same point. Any of those two. Okay? And just to give you some advice, when it comes to geometry reasons, if you give your reasons based on examination guidelines, you will be on the safe side. You are going to be on the safe side. If you go for private tuition, the private tutor doesn't talk about examination guidelines, then next time you meet that tutor, you must tell the tutor, why are you not telling me about the examination guidelines? Why? Okay? So, the reasons based on examination guidelines are very important. Okay? So, from here, it becomes a piece of cake. We can now substitute the Sn by Pn. So, I'm just going to carry on here. So, I'll say, therefore, En is equal over Pn is equal to Pn over On. And then say therefore Pn squared is equal to En times On. And then you're done.
So we still get 3 marks if it's just.
Alright, I'm realizing that this part here of the midpoint theorem for this question was not necessary, but I'm going to use it later.
If you just said it's perpendicular from right angle vertex to hypotenuse.
For which part? That we want to prove here that this one here, P E squared is equal to OE times En. Do you know that from these lengths here, you can identify the triangle? Okay? You can identify the triangle. So you can write this, you can split this up and write this PE times PE, that's equal to OE times En. Okay, let's start with this PE, this one, the first one. The first PE, if it's going to be this one here, okay, let's consider that one. Which of these two lengths is it gonna be in the same triangle? OE, okay, you can have OE, okay, you can also have EN. Do you see that? So if I use this color, I can go in that direction. If I use the other color, I can go in that direction. Okay? Now that can give me a clue now in terms of which triangles you're supposed to prove that those triangles are similar triangles. Okay? This PE, this one here, from what you can see there, it means that we have a common what? We have a common side. This becomes a common side. It appears we have got PE and PE. It means we have got a side which is common to two what? Two triangles. Then, so which two triangles? Right, you can take this one here or that one there. Right? But the naming now, you have to be very careful. So in triangle, I proved that some of the angles are equal to 90 degrees there. Right? So the one that I'm going to start with is E4. E4 is equal to E1. Okay? But before I do that, I'm not going to name the triangles for now. Okay? Because I need to do it in the correct order. So number one, we want to prove that to prove that two triangles are similar. So if I start with this PE, for triangle PEO, right, it's opposite what? O1, right? It's opposite O1. Then what that means is, okay, let me do it this way. But I know that P1 is equal to M2. So let me not stress myself here. So I'll just write P1 is equal to N2. This one was proved already. Proved in what? Question 1. We proved that already. So you must see it. Then E4, I think there's somewhere where if you didn't write it down, then I suggest that you prove it. That E1 is equal to E4. Right? But we know E3. E3 is equal to E1. Okay? E3 is equal to E1, and both are equal to 90. Why? Because they are vertical what? Opposite angles. Okay? Also, E4 is equal to E3. What's the reason for that? Here you can say sum of angles in a what? In a triangle. Sorry, angles on a straight line. Please, these are not the only reasons. You can write it based on your understanding. What I mean by E4 equal to E3, what equal to 90 because the angle on a straight line is because if we know that E3 is 90, we have proved it already. So to get E4, you subtract what? E3 from what? From 180. That's why I wrote angle on a straight line. So what this means is you can say therefore angle E4 is equal to E1. In fact, I need to write it down vice versa. Did you see this when you're writing the test? Huh? Are you seeing this? So I've got two pairs of corresponding angles. So the third pair is going to be, we're going to have O1 is going to be equal to what? P2. Am I right? Huh? O1 is going to be equal to what? P2. So, okay, let me write it here, the different colors. So number 3, it will be angle O1 is equal to P2. And the reason here, sum of angles in a triangle. Okay. Now once you do this, then you can name them correctly here to be PE, PEO. Okay. And the other one is going to be NE, NEP. Okay. Please, the way you name it, or the way you might have named these two triangles might differ slightly from me, but I'm naming based on my corresponding what? Angles. As long as the angles are corresponding, then it's fine. That's why you need to be very careful, especially if you are given the length of sides without being told which triangles are similar. Don't rush to just write that this triangle, in triangle this and that, because you might end up identifying incorrect corresponding angles. Okay? So I suggest that you don't write it, you prove first. After proving, then you go back and put the what? The names of angles. You work smart because you may, if there is a mark allocated for naming the triangles, you may be penalized. Okay. What is the word? I think it will. Okay. Right? Then, therefore, PE squared is equal to EO times EN. Then you're done. Okay? So it's not loud to myself. Okay, so those two triangles are similar. If they are similar, it means that PE. Okay, so we've got number 4 there. Let me use count. So we are going to have PE over PS is equal to EO over SR. That's equal to PO over PR. And the reason for this is because they are similar triangles. Okay, don't forget to write that. Whenever you write that the ratios of corresponding sides are equal, there is similar triangles. And then from here, we need to identify what OE is, what RS is. Now, what do we know in terms of the ratios? PE over PS. This is PE over PS, right? We can write a ratio based on that because PE is half of PS. Remember, we proved that PE is equal to ES. We have proved it before. Okay? Then this PO and PR, okay, we can also use it if you want. So you were spoiled for choice here. Either you use this ratio or use that one to determine the ratio of EO over SR. Okay? You had two choices. Well, which one can I choose? Let me choose. When I did it on my own, I used the first one. Let me use that one. Right? PO is equal to half of PR. The reason for this is that G is equal to 2 times radius. Okay? So what this means is my EO over SR is going to be equal to my PO is half PR, so I can put my half there. This will be half PR over PR. Okay? Now, when you want to simplify this, these two cancel. So you can end up having EO over SR is equal to what? Half. Now, what does this mean? This implies that the ratio of EO to SR is going to be equal to 1:2, not 2:1. Okay? Not 2:1. This means you need 2 EOs to get SR. That's what it means. Okay? It's 1:2, not 2:1. One of the answers that I saw was 2:1. It's not 2:1, it's 1:2. If the fraction is like this, when you write the ratios, you keep this to the left of the column and then you put the SR on the other side. The numerator, you put it on the left and the 2 on the right of the column. And then you're done. So, okay, then you're done. Okay. There are some learners who use the midpoint thing, but it had a connection, yes, because OP is equal to OR and also PE is equal to SE. But the question was saying use similar triangles to do the question. Okay? Right, any question? Any question? Do you see that it was not as difficult? Can you talk?
Yeah.
It was not as difficult. Then the next question. The next question, if you go back to the original question, right? You need to know what is Pn squared, what is Pe squared. Now it looks scary because of the way it's written, but it's so easy. In actual fact, this number 5 here, it's probably one of the easiest in this whole question. I'm serious. It looks scary because of the way it's written, but it's not that difficult. So if they're on the right hand side from there on. So for question 5, you have Pn squared over Pe squared is equal to En times On all over Oe times En. Okay, these two are like terms. They're going to cancel out. So you end up having Pn squared over Pe squared is equal to On over Oe. Okay? But we have already done something in question 4. We proved that OE is half of RS. We proved that. Okay? So to bring in this RS, it has got a connection with that OE. Okay? So, but here we say, but OE or EO is equal to half RS. Okay, where did we get that? Okay, I will suggest write a reason here. This was proved in what? In question, maybe we can call it question 4 for now. Okay, or you can say proved above, whichever you want. Then from there, write Pn squared over Pe squared is equal to On divided by half Rs. And this will give you Pn squared over Pe squared is equal to this. It becomes 2On over Rs. You need to come up. Okay, it's 5 marks, so some of the parts I would give you 2 marks for knowing this. Okay, I'll give 2 marks for being aware of it. Okay, obviously I will give a mark for showing that and for the division. Okay, I might give a mark here, then you can make it 5. Okay. No, the answer is just, it's a proof. You don't get a mark for the answer. It's a proof. Okay?